And we are back looking at yet some more power rules. Some of these are one of them is really tricky and one's just a fun fact. So the first one is a fun fact. Anything to the zero power is 1. And even in high school, I'm constantly asking kids, okay, anything to the zero power equals what? So kind of keep that in mind. And if you try it on your calculator, you'll be able to try it over and over again. But any number you put to the zero power is going to come out to be 1. These two are really the same rule. They go together and they deal with a concept that is kind of challenging. And that is, what if you have a negative power? Because you can't have a negative power in your answer. I had said in the previous video, when you're done, you want to do like an answer check. And the thing that I told you to check for last time was that you have no repeat bases, meaning you don't have any repeated letters or anything like 5 to a power or x's to a power. You can't have those written more than once. Now there's going to be another thing you need to check when you do an answer. Your answer can have no negative powers. So those are things you want to look for when you're done, because if it has repeated bases or it has negative powers, your work is not done. So how do you get rid of those negative powers? Negative powers don't make anything negative. So that's kind of tricky. When you have a negative power, it's a flipper. It basically is a reciprocal of a to the n. It flips things over. So in this statement here, the original 1 isn't over anything, which means it's over 1. And then when I flip that over and put the 1 on top and move that negative power into the basement, it becomes a positive power. Likewise, if you have a negative power in the basement, like we do in the second example, it has to come up out of the basement and go onto the top of your fraction in order to become positive. So negative powers move things from the top to the bottom or the bottom to the top. There's a couple of different ways to look at problems, and so that can be tricky too. You might be working on a problem and then look at my work and be confused because we did a little differently but got the same answer. Or you might work with a friend and the same thing happens. So let's take a look at how this kind of problem can play out 2 different ways. But in the end, as long as you're applying the rules correctly, you get to the same spot. So let's do this one the old way. The old way says, hey, I have the same base multiplied together, so I can go ahead and add my powers. -4 plus 4 will be 6 to the 0 power, which I just learned up here. Anything to the 0 power is 1. All right, let's look at this a different way. Let's say you take what we just learned and you say, hey, I just learned that a negative power has to move into the bottom if it was on the top, and into the top if it was on the bottom. Well, without a bottom in this problem, everything must be over 1. So this would have to move into the bottom. So I have my 6 to the 4, which was this guy. And now this 6 to the -4 moves into the bottom, but when it does, it becomes positive. Well, now I have something over itself. These 6's repeated 4 times cancel all of these, and anytime you have something over itself, it is 1. So you can kind of treat the problems in whatever manner you see first, but if you look at my work, don't panic if you did it a little different way but got the same answer. So this also goes back to something we learned before. When you're bringing a power in from the outside, you multiply them together. So this would become 4 as my base, and then -2 times 2 becomes a power of -4. But I can't leave that as my answer because I can't have repeat bases and I can't have negative powers. Since there isn't a bottom, it's currently over 1. So however you want to think about this, you can flip it over, meaning the 1 goes on the top and this moves into the bottom. Or you can just think this is on the top negative, so it has to move into the bottom to become positive. And in order to show that it's in the bottom, you need a top. So you put that 1 as a space saver. However you want to do it. All right, how about here? Well, currently my 3 to the -4 power is on the bottom of a 1. So I need to flip that over and bring that to the top and technically the 1 to the bottom. But when you have something over 1, you don't need to write it as such. And I would just leave it then as 3 to the positive 4 power, because once I bring it up, it becomes positive and I can eliminate the over 1. How about here? This one looks kind of tricky. What I would do first is move this negative. Negatives are very tricky. So I take it and say, okay, that's a negative on the top. I need to move it into the bottom. And when you clear out the top, you have to put a 1 as your space saver to say, hey, I still have a top to this fraction. I just took everything out of there. When you bring that 5 to the negative 1 to the bottom, it becomes a 5 to the positive 1, but you already have a 5 to the second down there. And that would mean a total of 5 to the third. And that's in the bottom because of that negative. So that moved into the bottom, became positive, and then combined. Because remember, this would be 5, and this 5 squared would be 2 more of them. So ultimately, I end up with a 1 on the top and 5 to the third on the bottom. All right, they're going to get messy. Everybody in here that doesn't have a power is really to the power of 1. This 3 is going to get multiplied in sort of like distribution to every power. So don't put 6. It's not 3 times 2. It's 2 to the first power, and then the power gets multiplied by the 3. Just like it's x to the first power, and then the power gets multiplied by 3. Y to the negative 5, and the power gets multiplied by that 3. Here, I end up with 2 to the third. Here, I end up with x to the third. And here, I'm still multiplying. I get y to the negative 15. Okay, so I can't have a negative power in my answer. The only part of my problem that has a negative power is the y. So the only part of my problem that has to hit the road and go into the other part, meaning the bottom in this case, because currently this is all over 1 because it wasn't a fraction, this part has to go to the bottom and flip over. So I have my 2 to the third, x to the third, over y, and then it becomes positive. That was the whole idea of moving it. And then the only other thing that you might see and do to simplify it is to think 2 to the third means 2 times 2 times 2. So you might actually write that as an 8. It's not important to me that you do that, but just so you kind of know in case I do it and you look at the answer key and can't figure out why it's an 8. So I'm done because I don't have any repeated letters and I don't have any negative powers. Wowza. Okay. Let's kind of go through our little checklist. Again, I used to say do the parentheses first. So if you have a power out here, get that in there through multiplication. And then what I like to do second now, I like to move the negative powers. And then I go on to doing the side-by-side neighbors like we talked about before. So if I have anything that's the same power sitting next to each other, I add their powers. And then lastly, I like to look top to bottom and see if I have repeats and go ahead and cancel those using subtraction. That is not like a rule that you have to do them in that order. I just like to approach them all the same way so I have a plan. So in this case, I'm going to do anything that's outside parentheses first, meaning, each thing is going to have to get multiplied, each power. So negative 2 is currently to the 1 power and x is to the 1 power. And each of those, everything inside the parentheses, will get multiplied by that negative 2. So my negative 2 will go from being to the first power to the 1 times negative 2 power. My x will go from having just a power of 1 to 1 times negative 2. Then I still have my y to the 5 over a negative 4, x to the second, y to the second. And all I did was this. Now I'm going to go through and manage my negative powers, not my negative numbers. Like negative 4 is perfectly fine to sit down there. This has negative power, so it has to move to the bottom because it was on the top. This has a negative power, so it has to flip over and move into the bottom. Those are the only two negative powers that I'm going to need to move. That leaves my y to the fifth upstairs. Now I'm bringing down my -2, which now is going to be to the positive second. I still have that -4 down there that it's going to get multiplied by. Now I'm looking at my x's. This x to the -2 from the top comes down into the bottom. It joins the x to the second that was already there. And then I still have a y to the second in the bottom. Okay, now let me look side to side and see if there's any neighbors that are of the same that I can combine. I'm going to go ahead and look at my numbers. -2 to the second would be -2 times itself and then multiplied by this -4. So all of those together, if you get out your calculator, are going to turn into a -16 on the bottom. The only thing I have on the top is my y to the fifth. Then I have two neighbors that are the same base, which is x to the second times x to the second. That's the very first rule that we learned. In that case, I add my powers. So 2 plus 2 becomes 4. And then I have my y to the second. Now I'm going to look and see top to bottom if I have any repeated letters, which I still do, because if I were to read this out loud, I'd be saying y to the fifth and y to the second, and I can't have the same base because, again, my rules for the answers is I check for repeated bases and negative powers. One common mistake that kids make is they move numbers that are negative. So like this -16 in the bottom, they like to move that, but it's not a power, so you don't do the power rules. So I have 5 y's on top, 2 on the bottom, and what we learned yesterday is that you find the difference. 5 minus 2 would leave me with 3. Since I had more to begin with up here, the extra 3's would be on top. The 3 extra y's would be on top. I have my -16 and my x to the 4 because all 2 of these canceled 2 of these, leaving me with 3 extras on top. If you need to write out the 1, 2, 3, 4, 5 of them on the top and the 2 of them on the bottom to convince yourself that it's going to leave you with y to the third on top, do whatever model makes it easiest for you to end up with the right answer. Now I check. Do I have any repeat bases? No. I have a number, x, and a y. Do I have any negative powers? No. I have a negative number, but that's fine. Okay. One last example. Let's take a look. I don't have any parentheses, so I'm not going to do that. I'm kind of going down my checklist that I like to use. Where'd it go? Here we go. I don't have any parentheses. Now I'm going to look and see, are there any negative powers to move? Sure are. The only thing that has a negative power is this y. That's the only thing attached to that negative power, and it's in the top. So it has to move to the bottom in order to become positive. So I still have my 3 and my x on the top. I have my 9, my x to the third, and my y that were originally on the bottom. And now I'm moving down a y, which will become to the positive third power. Now I'm going to look for neighbors, because if I look at my little list, I didn't have parentheses. I moved my negatives. Now I'm going to see if there's any repeated bases sitting next to one another. Well, there is a y and a y sitting next to one another down here. This one doesn't have a power written, so I know it's a 1. So those two are going to get added together, and you're going to end up with y to the 4th. But my last move that I like to make is to look top to bottom and see what cancels, what reduces, if I have numbers that need to reduce. So looking at what I've got left, I'm going to take it one thing at a time. The number part, 3/9 can reduce down to 1/3, just like it does when you're reducing regular fractions. I have 1 x on the top and 3 on the bottom. So if you think about how that would play out, I'm going to have 1 that cancels, and it's going to leave me with 2 because that's the difference between the 3 and the 1. But the 2 extras will be on the bottom because that's where I had more to begin with. And then I have my y to the 4. I'm going to just put this one more in the middle because I didn't realize I wasn't going to have anything else on the top. So when I'm done, I have 1 over 3 x to the second, y to the fourth. I do not have repeated repeated bases. I do not have negative powers. So I am good to go. And again, these are really a lot of steps, really a lot of picky details. That's why I personally just like to have a way that I do every one. And if I don't have parentheses, I get to skip that step. If I don't have negative powers, I get to skip this step, and so on. But it just gives me a way to proceed through these that I can use consistently. So this is really big brain stuff. You're probably going to have to revisit the examples, the filled in notes, possibly rewatch parts of the video. You have to pay really close attention to detail when you go to do your assignments, because little tiny things can happen real easily. And in an answer like this last one, for example, or the two that you can see here, if you're typing your answer into Schoology, there's a lot of little things that could go wrong. And maybe your 8, your 3, your 15, your letters, something could be a little off, and then your answer is going to get marked wrong. So really take your time before you go ahead and enter any answers. Have a great day, you guys. Good luck. And if you need help, make sure you're looking for those drop-in sessions. Have a good day.